All right, so now we need to find some factors of a number. All right, what are factors? Factors are the numbers that can multiply together to create the number that you're looking at. So for example, let's say that we have the number 15. What are factors of 15? Well, let's see, what can we multiply together to have an answer, a product of 15? 1 times 15, that equals 15. All right, so 1 and 15 are factors of 15. 3 times 5, that multiplies together to equal 15. So 3 and 5 are factors of 15. You can't equally multiply whole numbers 2 times anything to equal 15. For factors, we're sticking with whole numbers, so no fractions, no decimals, just like a number that you could count on your fingers, 1, 2, 3, 4, 5, that kind of thing. So that's actually it for 15. We have 1, 2, 3, 4 factors of 15 and 2 factor pairs. Remember, pairs are 2 numbers that go together. So factor pairs are 2 factors that multiply together to have a product of the number you're looking at. So 15 in this case. So we have 2 factor pairs here and 4 distinct factors. Distinct is a word that comes up a lot in this unit. Distinct means different or unique, not repeated. So, for example, 15 times 1 also equals 15. However, I didn't list that again because I already have 1 times 15 right here. I do not need to repeat them just in flipped order because the commutative property of multiplication tells me that I can multiply in whichever order I like, and I'm still going to have the same answer. Therefore, 1 times 15 is the same thing as saying 15 times 1. It just looks a little different. It looks like it was flipped. I do not need to repeat them again and again because that just takes up a lot of time and space. I want distinct factors, not repeating. All right, let's try another one. Let's say the number 3. There are only 2 factors, 1 and 3, for 3. That means that it has 1 factor pair, and that's it. 1 times 3 is 3. There's nothing else that you can multiply whole number-wise to equal 3, so that's it, 2 factors. For numbers like this, it's pretty easy for us to quickly come up with, oh, well, the only things that you can multiply together to equal 3 are 1 and 3 itself. However, there are some numbers called composite numbers that have lots of different factor pairs. Prime numbers like 3, they only have 1 factor pair, but composite numbers have lots of them, and it's really easy to sometimes skip over them or forget them. So what we do to keep track of all of our factor pairs is create something called a factor rainbow. Now, a factor rainbow looks like a rainbow when it's all done. Let's pick another number, say 12, to create a factor rainbow for. So what I do is I start on the outside of my rainbow. I'm going to create a big one because you never know. There are some numbers that have a lot of factor pairs. You want to give yourself space. And I'm going to start with the smallest factor I can think of, which is always going to be 1. You can always have at least 1 factor pair for every number except for 1 itself, that it has distinct factor pairs of 1 and itself. So 1 on this end and 12 on this end. Because if you connect them, 1 times 12 has a product of 12. Anything else? Well, I start with my 1 and then I start counting up. 2. Does 2 multiply together with something else to equal 12? Well, 12 is even, so yes, 2 should be a factor. 2 times 6 is going to create another rainbow arc that has a product of 12. I'm going to separate each of my numbers by a comma because I don't want to accidentally think when I'm grading that you think 612 is a factor of 12. I want to have those commas in there to separate them. Now I'm going to go to 3. 3 times 4, oops, sorry, I changed my color. 3 times 4 also equals 12. So I have another rainbow arc there. Then I go up 4. Oh wait, I already have 4 on this side of the factor rainbow. So if I can cut a line down the middle, I have 1, 2, 3, and then my next factor is on the other side. That means that I'm done. I've used up all of my factors because 4 would be another factor. 5 is not a factor. 6 is another factor. 7, no. 8, no. 9, no. 10, no. 11, no. 12, yes. I don't want to repeat again and again because that just makes more work for myself. If I have them listed once, that's enough. They are distinct factors. So this would be my final factor rainbow. With 3 arcs, that means 3 factor pairs, 1, 2, 3, for the composite number 12. Each of those factor pairs could then be turned into an area model, a 1 by 12 area model, a 2 by 6 area model, and a 3 by 4 area model. Oops, running out of space. But we don't have to. That is your factor rainbow. It looks like a rainbow. If you're really into it, you can draw some clouds around the bottom. You don't have to. That's your factor rainbow. However, a lot of times you'll be asked to list factor pairs. Drawing this rainbow is not enough. That's not like a mathematical way to present your answer. If someone asked you for factor pairs of 12, factor pairs of 12, then you'd want to list them in pair form. Pair means 2, so I would list 1 times 12, that's a factor pair. 2 times 6 is a factor pair. 3 times 4 is a factor pair. I could have listed 12 times 1 or 4 times 3 instead, but I only need the 3 distinct pairs. I don't need to list 12 times 1 because that's not a distinct factor pair. It's the same thing as that. And I don't want the person grading my homework to think that I think those are 2 different shapes or 2 different factor pairs. I can write it whichever way makes me happy, but I'm only going to write it once. This would be what it looks like to list factor pairs. If someone asked you to list factors of 12, then I wouldn't want to have them together. I might say 4 is a factor, 2 is a factor, 1 is a factor, 12 is a factor, 3 is a factor, and 6 is a factor. Notice they don't need to be in any particular order when I list them in factor pairs or in just plain factors. They do need to be in order when I list them in my factor rainbow, because order is what helps me count up and make sure I'm not missing any. So yes, in numerical order from least to greatest for factor rainbow. No, it doesn't matter for factor pairs or for factor just single factors. Either one of those that can be in whatever order you want. But a factor rainbow, unless a question specifically asks you, draw me a factor rainbow, which is pretty rare, you want to either be listing this kind of list or this kind of list. You're always welcome, and I strongly encourage you to draw yourself a factor rainbow off to the side, but that will not be graded as your final answer. I'm either looking for this or for this, based on whether it says factors or factor pairs. And those are factors.